So, hello, greetings. My name is Wincyr Dela Calzada,
And I am Johann Gabriel Sebastian B. Telesforo.
and we are here to discuss about the stack operations and data structures. So, quick overview of stack operations, Mr. Telesforo.
Okay, so stacks are used in many different types of computer applications. For example, the web browser. Almost all web browsers have back and forward buttons that allows the user to move backwards and forwards through a series of web pages. The back button returns the browser to the previous web page. Click once more, it will return to the previous page. So that's how the stack of the browser works. So specifications. So the four operations that the stack uses are the push, which places a new element into the collection, pop, which removes the topmost item from the stack. Top returns but does not remove the topmost item from the stack. Is empty is to determine whether the stack is empty or not. So that's the quick overview of stacks.
So, we will now move on the visualization of the stack. So, let me share my screen. Uh, is it visible?
Yes, is it? Yes, it is visible.
Okay. So, to explain first, this is our given expression. We have a open bracket x, a open parenthesis y, close parenthesis, another close parenthesis, and closing bracket. So our initial pointer will always point at the first element of the string, which is this uh, open bracket. So as you can see here, it is already explained, but it is already explained. But I will just explain it to you quickly. So first, since this is a open bracket, we will push this into the stack. And mind you, we will only be focusing on the symbols here. We will disregard these letters. We will be focusing on the symbols. So goal namin symbols. Letra iwan.
E1.
Kahit letra pa yan. So ayun. Uh proceed. The initial pointer will move up after pushing the first element, which is this open bracket. Then our next element, which is this open parenthesis, we also push that, and then move our pointer up. Since we will be disregarding y, so our current pointer is now in this closing bracket. So first we must check if the top of the stack and this closing bracket matches. If they are a pair, we will pop. So in this case, the two match, so the top of the stack will be pop. So after that, we have this another closing bracket. So we will now check if the top of the stack is a pair, but since it's not, we will now stop the program. If not match, we will need to terminate the program here. Since there is still an element left in the stack in the closing bracket on the right side does not match the top of the stack on the left side, therefore the expression is not balanced. So if you're still a little confused about that, we have a balanced example here, visualization. So just like earlier, we have symbols, open parenthesis, close parenthesis, close parenthesis. So first, this is our pointer here. We will push this to the stack. It's now being pushed. The pointer will go up, and then we will still push this since it is still an opening parenthesis. So push, and then our pointer will go up. Then the pointer is now pointing on the close parenthesis. Since it's close parenthesis, we will check if they are matched. If they are paired, then we will pop. They are now popped, and then the pointer will go up, and then since this is a close parenthesis, also close parenthesis, I will still pop this top of the stack, and then the pointer is now gone since we have finished pushing the elements in the string. So the stack is now empty. Since the stack is empty, therefore it is balanced. So that's our visualization. So
We will now
next
proceed
is
to the coding part. So, Mr. Windsor, Dela Calzada, kindly present.
okay. So we'll just show you the implementation of our stacks. So if we run this, as you can see here, we initialized S new stack ops 5. This is the size of our stack and how many elements can it fit. So we push 5, push 8, push 2. So after that, if we run this, we will now have 5, 8, 2. So it's not stack empty. This is no. This is the two string uh override two string. So here is the stack empty, false, since it has an element 582, and the top element is 2 since it is the last element that is being pushed. So where did we get this stack empty uh top, this two string? So it is all uh here. So Mr. Telesforo, will you explain this override system?
So
Public
the
string to string.
override public string, the toString is the method the method toString has already been in the netbeans. So we initialized override so that the method from the netbeans will not be printed ha- printed, but the public string, the toString uh, code will be imprinted instead of the NetBeans implemented one. So that's the explanation of the public string to string.
So this is for the push, the codes for the push, the codes for the pop. This is this top, which is this. Top element is 2. This is the determine, which is the top element and is empty. Determines if the stack is empty. Boolean. So I hope you guys understand our discussion. Leave a like, subscribe. Thank you.
That's all. Thank you. Thank you for listening.